So then the next stage, which we wanted to discuss, was okay, water quality testing. I mean, so we thought it was a good, idea for a field trip, and Dole, of course, was doing a good one on May 14th, and Randy was kind enough to volunteer to implement this in his school. So we thought that if we could give a complete package, because we have all these inventory of the linear sensors and the Pasco sensors. So if you could do pre and post testing, take the kids to a field, or even in a classroom environment, whichever way you think is appropriate. So we have these sensors to do pH, turbidity, temperature, dissolved oxygen, phosphates, nitrates, ammonia. I mean, there's a whole inventory, and Sean can help you provide the list of sensors we have. So feel free to. I don't know if you already have loaned them, but if not, feel free. And so today I wanted to give the demonstration of the Pasco sensors. And the reason this all came from Justin. Some of you may know him, Justin Kagi. His idea was that how we were using all these iPods, and as the technology is moving forward, to excite the kids. If you show them like everyday gadgets being used for technical stuff, they can really relate to it. That it's fun. So the Pasco sensors, the great thing about them is that they can interface with your iPod, your iPhone, or your iPad, to collect data. So that's what we wanted to do. So first step is this AirLink. So Pasco AirLink, this is what you need. This is a connectivity interface. So this port on AirLink allows you to connect any sensor that Pasco makes onto this AirLink, and what it does is via Bluetooth, you're going to connect your iPad or iPhone to the sensor and collect the data. The data is going to be directly transmitted via Bluetooth onto your device. So as an example, let's start with the pH. So then we have the water, we can do pre and post also. So this is the pH sensor. It's a pH and temperature sensor, so it has two ports. On this side, you can see this port is for this pH probe. Okay, this on my left side, your right side, is for the temperature. And let me show you how the temperature one looks like. This is the temperature probe. Okay, so you just plug it in, and then when you dip this end into the water, it's going to collect the temperature of the water. And this side is pH, of course. So let's see how to connect these things. So let me use my iPad for this thing. So there's an app called SparkView, SparkVue, SparkView, that Pasco specifically made for interfacing these devices to the sensors.
Is it free or
It's free. On the App Store, you can download it. It looks like.
That's why.
Spell it again. SPAR.
Okay, yeah, that was on the iPod that we borrowed last year. That's why I remember the name.
Yeah, it's SparkVue, SparkVue.
I think we last year we had 2 or 3.
Yeah, we did too.
I'm just clearing my interface so that I won't start fresh with you. Okay, so this is my SparkVue. Okay, so when I click on it, it shows this interface which just says experiments. Okay, so now the first step is to connect your AirLink to your device. Okay, there is a power on button out here on the AirLink. It's a black color switch. Okay, to charge this thing, you have this USB cord. Okay, so you plug it into this port here and connect it to your computer. That's how the AirLink charges. They recommend before first use, you charge it for about 4 hours. Okay, and the indication lights are here. There are these 3 LEDs. There's a red LED here, there's a yellow LED on this side, and then there's a green blinking LED that you can see. I don't have the manual with me. I mean, I do, but you can read through it, and it shows what LED indicates what in terms of the power levels and whatnot. Okay, so once you switch this on, the green LED starts blinking. So now it's in Bluetooth mode. I mean, it's sending out its address. So what we're going to do is, we're going to go to our iPad, go to settings, okay? Go to general in settings, general, and then in general there is Bluetooth. So this is how the general interface looks like. In that there is Bluetooth right here, okay? You turn your Bluetooth on, okay, and it's going to start looking for the devices. Every AirLink has a unique ID. So the AirLink is appearing here now, AirLink 2 36016.
Oh,
okay. And me show you this thing. Right. So the A-link. Okay. So now, if you have multiple of these in your classroom, you know, everyone is going to be sending out a unique ID. So you want to make sure your students connect to the ones that they are holding in their hand, okay? So that's the idea out here. That's why the unique ID, because 5 of them turn on in the class at the same time. You want to know that you're connecting to the right one and not to the table who's, you know, far away from you. Okay, so then AirLink, it says not connected right now. You just click on it and it's going to start pairing with it. Okay, and now it's connected. So it changes the connected status. Okay, so just clicked on it and it's connected now. Oh, I'm sorry. What did I do? I just switched to mine. Here you go, connected. Okay, so now both of them are paired. Next step, going back to our Spark view. Okay, Spark view interface says experiments. Now, let's connect the sensor to the AirLink. So, pH probe connects on this port. This is how the pH probe looks like. This one, as I said, there's a port on this side. Every sensor on Pasco is going to connect to this port in one way or the other. There's sometimes a connection cable, extension cable, sometimes it directly hooks on. In this case, it directly hooks on. Connected. Easy. Next step. Experiments, as I showed on to you on the Spark view, there's an add button on the top right corner, a plus sign. Okay? Click that. It automatically, this is the fun feature of this particular thing, it automatically detects that the current sensor you have connected is a pH sensor. And how you know that is your measurement says in pH. The sampling rate is defined as 2 Hz, which is about half a second. Duration is continuous. It's going to do a continuous recording when I start recording from it, okay? You can put a title on this. Okay, so I'm going to title this experiment like pH. Sorry, pH, okay? And then you save it. Now you have a title for your particular experiment. You show on this side. So automatically detected pH, so the measurement was in pH, 2 Hz, sampling frequency. If you want to edit, you know, so let's add this thing. So now in your experiments list on the main menu, a pH appears because I named the experiment pH. Okay. So if you want to edit this, so if you click again on that arrow that appears on the right side, you click that. It shows that edit on the top. You click the edit, it will allow you to set up your duration of the experiment. So right now it's continuous, that's default settings. So by default it's going to do a setting on this thing that's going to do a continuous recording once you start recording the data. If you want only a 30-second recording, so you click on continuous, okay, you say automatic stop is off, you turn that on, and now it gives you stop after how many seconds? Okay, so then you can set it up if you want 30-second recordings, 15-second recordings, 1-minute recording, or whatever you want your experimental duration to be, like how long the students need to collect the data. So that's how you do it. Okay, I'm going to keep it on continuous for now. So that. And then when I go back to experiments, to enter the interface, the way is where the pH, this side, anywhere other than the arrow, if you click, it's going to enter the experiment interface. That's your experiment interface. Okay? On the bottom you see that green play sign, play button, that's to start the experiment. So, Sean, can you help me on here? So you hold the probe, I have to show on the data, okay? So we're putting the probe into the water that we have here, okay? And then I hit the play. Starts showing the pH, okay? Very easy to use, there's like...
Oh, that's a nice graph.
And you can do like all the iPad features on it, you know, stretch it out, squeeze it in, so whichever way you want. So Shanki, please keep holding, okay? So I'm like zooming out, zooming in, whichever way you want. There are 3 different kind of graphs, okay? This is like a graphical view. If you swipe it, it gives you a meter view. What the pH looks like. As the reading is changing, it's gonna move it.
Okay, so it's current and
yeah. And then the actual value, 7.66.
I like that.
Okay.
That is
Wow.
good.
So how come we didn't see that last time? Remember did we get to that where we could
But
actually?
you didn't do it on your iPad.
So
right?
it
It had
remember
different types. I don't remember exactly what, but it did have different types of displays.
Graphical view, you're gonna tap on it,
Because I remember
make
that.
that disappear, the interface disappear, then you can pinch it and, you know,
Will
zoom
it
in,
make like
zoom
an
out.
average?
Yes,
or-
and that's what I'm getting to.
Oh.
So, sorry.
So with the application on the iPod, it's the same.
Yes, exactly the same. It just gives, helps a little to do it on the iPad, bigger screen.
Bigger.
So this summation sign that you see here on the bottom right, if you click that, it shows you the mean, the standard deviation.
Ooh, standard deviation.
So in a way,
They may not know it, but when you say it over and over, somehow gonna click in their brain. I'm telling you. As I said, repeated
the
examples.
minimum value it recorded, the maximum value of pH it recorded, the mean,
That's so
and it's
good.
moving. Standard
Because we were
deviation, and then
calculating
count.
the past couple of
Count
years.
is the number of samples it has taken till now. So that is like, because every half a second it's taking samples of 220 samples it has taken, so it keeps moving until I stop this. The way to stop it is again that play button, which is red in color now. You click that and you're done.
Oh.
Okay?
Wow.
That's it. Thank you.
Wow. And then it'll save it on there.
Yes, you can save it. So the way you do that, you see number 1 here now. Okay. Experiment. You don't want to rely on the first run itself. You want to take 2 or 3 different
Yeah.
runs. Okay, Sean, sorry. Can you hold it again? Thank you. Okay, so I want to do a second run. Okay, you hit the play button again. Number 2 appears. So second run is recording now. It's totally independent from your first one. It shows in that green bar below. So it's an independent run now.
I can remember all of the steps.
So you see that, Randy, the green one on the bottom? Now it's the second run. That's a graph developing for the
Oh, that
second
helps
run.
with different colors too.
Yeah, and then say you want to do a third run.
It has similar features.
So that's why if I did it for 30 seconds,
It makes sense.
I can at least say
Yeah.
more accurate, right? Because then if I just said duration, and the kids would be, to make it simpler, like I can just put 20 seconds, leave it in there.
Yeah, that's the way, for 30 seconds you're taking a reading, do 3 runs, and then
The
take
same
the
amount of
average of it, that will be your
Okay.
final reading. Because in the first run, it takes time to, the sensor to get the first reading.
Oh.
The second and third run, it's already, calibrated to that particular level of what source you're
So do
putting
you
it
think
in.
that I should run the first trial longer?
I would suggest, just for because it takes a few more seconds for the system to calibrate to that particular level.
Okay.
What source you put it in. Because if you think about it, right, if I'm directly from here, I put it into boiling hot water, the temperature sensor, it's going to spike in the beginning. So you don't want that reading to be, because it takes time to adjust to that particular level. What is the temperature of the water? So just for that, I would say that first.
Or I just could just say, leave it in there for X amount of seconds to calibrate, and then
Yeah.
run 3 additional ones.
Additional
right?
ones.
Okay.
That would be the best way.
Okay.
And then again, you can see very, very great. This was my first time. Yesterday I played with them. I had never used them. I was pretty impressed at how simple it makes life in terms of doing the
That's super
readings.
neat.
So you got the pH. Thanks, Ron. So let's do the temperature now. Can you put this one on and then put that sensor? Okay, additional features. You want to send the data to yourself. So bottom right, just like an email in an iPod.
Wow.
Email data as a zip file, as a CSV file. And you can email the data to yourself, to your students, and then you can evaluate it later. Okay, easy. Then you want to take notes. Students want to take some notes on what they were doing. On the top right is that pad icon, notepad icon. You could do and put in your notes out there and whatever you want to do about this. So they want to make a report while they're working on it, you can make that. So good features.
Okay, so I should probably spend one day at least teaching them how to use that stuff.
Okay, so
Yeah.
we're done.
Yeah, right.
Yeah, that's good. So
I don't mind doing the data analysis part, because that's what we're doing
Okay.
fourth quarter, yeah.
Because like what we
So
did
lessons
last,
based on,
what we'd be
yeah.
doing is we pull a few kids to be the handlers of the equipment,
Yeah.
and then we teach those few kids, and then they're part of a bigger group that will do the data.
Yeah,
Okay,
so
just
Yeah.
because this was a dual sensor, pH and temperature, so now Sean has plugged in the temperature probe into it. And the same thing, on the experiments window, you hit that plus sign, okay? And then you title it, and now this time I'm going to do temperature. And make sure the measurement units, because it is one sensor that collects both the ones, so you click on this where it says measurements and pH, and then you select temperature.
Oh.
Okay, and then units, you want Kelvin, you want centigrade, you want Fahrenheit, whichever unit you want the data to be collected in. Let's do Fahrenheit. Okay, and then you done and you're saved, and then again done, and now you click temperature. So a new interface is going to open. Sorry, there you go. Okay, for temperature. Now you hit the play button, something you put in.
I know.
And here it starts recording the temperature now.
Wow.
So
Why
mean.
did it seem so much difficult?
I know.
And last year, remember how,
We were having so much trouble
Yeah.
with getting that set up and.
Getting these set
Because I
up.
think we didn't know what we were doing.
Yeah.
Well, I didn't know what I was doing.
they did the iPod last year.
Yeah, we did the
But
iPod.
we did the
Same
same
I
thing,
yesterday
right?
used my iPhone, then I just pulled out my
We
iPad.
had
I was
the
like,
same
I want to
pros, the
But
same
we're having
equipment.
problems doing connections and getting it, I don't know, something.
You know, I wonder because we had two of these air things.
I don't think,
I'm
yeah, we
wondering if
programmed it.
We didn't pair
We
it
just
correctly.
like, yeah,
Yeah, possibly
like
that's
turn it
what
on,
it
let's go.
Yeah.
Because we had a hard time because we didn't have the password.
72.94.
Alright.
So
we
I
had
don't know
trouble
how we-
pairing, even
Yeah.
pairing was
We're
difficult.
all like,
So that's the first
yeah,
set.
that's easy.
Okay, thanks.
I know, that seems
You know,
Let's
weird.
get on.
So you don't have anything for these Pasco things in your possession,
No,
only for
because we
him.
borrowed
Okay,
everything. Yeah.
okay. So if you wanna play around, especially if you wanna see it done through the iPad, right? Then let me know and I'll get for you from Sean, because we still have a little bit more in the inventory. It might not be all the sensors that you want, but I think even just a few
little,
to
yeah.
play
practice,
around
yeah.
with to
Because I know
see
we had
how
at
to
least those
do
two
it.
last year.
Then we can, you know,
Yeah.
Yeah, I gotta download all that.
yeah,
Then I
so,
can make the instructions
Sean, maybe
too for the
they
kids.
can take with them, can you see what you have now in terms of sensors and let them play around with it? So that they can play around with it, right? Because you have the iPads, so that, and give it to them today so they can start, you know.
Is this video gonna be available?
Yes.
It's like watching a YouTube video, you know,
Yeah,
on what to do,
Yeah.
on how to do it.
and the kids are good at that. We do
That's
have
what I
another
do.
video though.
That's what I do before I watch, I present the lesson, I watch the YouTube.
We do have another video though,
Yeah, we
on
do.
the Pasco.
Okay, good.
Yeah, there is a
That's right, that's
tutorial,
right.
so there is a
Oh, yeah.
tutorial.
So I
Yes,
have
it
that on
is.
my personal iPad.
Good.
Yeah, I remember watching that.
Because then we got a disc last year, so I had
That's
kept
right,
it. I
yeah.
downloaded and kept it, so if we need it.
Okay, so this is my personal favorite from yesterday. I don't know, because I saw the
This
hack.
one you gotta put it.
I don't know, the company HACH
Yeah.
is a company which makes turbidity meters and a lot of water quality testing equipment. And we took one of those meters to Thailand for doing our own turbidity testing. And then when I opened this, I was like, I was expecting something else. When I saw that they had miniaturized the hack into this one, I was very happy.
You're to turbidity now.
I'm sorry?
Going to
That's
do turbidity.
Yeah, yeah.
Okay.
So I was very happy that they actually miniaturized the same concept
Oh.
and they didn't really change anything. That's not a dipping probe or anything, because you have to like bounce light off the
Yeah.
sample, right, to
Right,
get
right.
how much reflection
Right.
of the light comes back, and that
Yeah.
gives you the turbidity reading.
Mhm.
So yeah, I was really impressed with this one. So this is our turbidity meter. This is the extension probe they give with it, so it's not gonna directly plug in this time. So we just like use this one. I mean, it can, but it's gonna be a little difficult this way. So okay.
So that's a whole different mechanism, other outside of the Pasco then?
Yes, all sets of passes are like different sensors. I mean, different sets.
That's a Pasco turbidity sensor that he's working
Oh,
on.
that one there?
Yeah. This is what we have in our inventory. And the reason why I'm encouraging him to do turbidity, because visually you can see, like
Yeah.
even this color,
Yeah.
you know, this it's turbid compared to your distilled water. But then, out in the field, we use
sorry.
the Seki thing, you know those that
Yeah, and it
circle?
doesn't.
Yeah.
And it's
It's
so
all the
crude,
same.
crude.
Yeah.
But then, this is where you can show them again appreciation for technology.
Yeah.
Where that one is
Sheesh.
so hard.
Where do I pick up those filters from? Any store?
These filters, we usually buy it online, Randy. I can give you that link. It's a
Okay.
vendor that we have called filterfast.com.
Filter fast.
Yeah, but if you want, I can find local stores, because I think Ben, our technician, told me that they're available like Home Depot and whatnot too.
Okay.
But I have to check and I can get back to you on that. Okay.
Great science project for next year.
Oh,
So
yeah.
Yeah, we should have science now, it's more
Oh, yeah.
interesting.
I
I
know.
know I should.
turbidity,
Oh, yeah.
I was debating science or math.
you're connecting the probe.
We can still do.
Yeah, right.
They like to see standard deviations, you know, analysis. They're pushing for that now.
Yeah.
Neat.
So one valve with this, because this is the output of that. Okay, so what I asked Sean to do was, this was Randy, your golf course water. and now I'm asking him to put another vial from the output,
Oh, okay.
so we can compare how well the system did on the reducing the turbidity of the water itself. Okay, so just for reference.
That's your turbidity kit there with all the little vials and everything?
Yes.
Okay. So
So
it comes with some of this.
you can calibrate this. Right now the system is calibrated. It comes with a little booklet on telling you how to calibrate the system. To do that, they have given this water, just like 100 NTUs. Okay, NTU is the unit of measurement of turbidity. I forget the N,
Yeah.
what it stands for, but turbidity unit. So, so this is the 100 NTU turbidity vial that they have provided with the kit. This is for calibration. So you put this, and then you put like a distilled water. It's a two-step calibration. So this is the distilled water. I've marked it already, so you can use it later.
Do they provide the distilled water? That's it.
They did not. I just poured it in yesterday.
Okay.
So,
Okay.
so you can use this and the 100 NTU bottle for doing your
Yeah, that's to
calibration.
calibrate.
And then I was just playing around, so I poured threw in some mud from outside into the vials,
Yeah.
like the turbid water here. Okay, so that's the clean one. Okay, yeah, you can see it. Okay, so let's start with 100 NTU just to show you the. So you insert the vial. Actually, the first step I forgot. Sorry. So you would want to make sure that there are no fingerprints on the outside of the vial or like any water droplets. So you just clean it with a cloth to make sure that the outside surface is clean, because again the concept of turbidity is bouncing light into the water and seeing how much reflection it gets. So you don't want external distortions on the vial. Just close that. So you add your experiment again. This time it automatically recognizes its turbidity meter that is connected. So you don't really have to set anything on this. It's automatically recognizing that it's turbidity. Okay, so title, I'll add turbidity this time. Okay, so again now I have turbidity. Click that for the experiment interface to pop up. Okay, that's set, and then let's record. So there you go, your graph, because that's the 100 NTU vial that I put in. So see around 100. The reading is 101.55.
So this is just part of your calibration. You calibrating it yet?
I'm not calibrating, I'm just
You're
showing that,
calibrating.
okay, because we know the value of it, so I want to show the accuracy of the system itself right now.
Because the calibration allows you to get a range, right? So the more you have this versus this, then your units will change. This is like a spectrophotometer, right?
Yeah, it is,
Yeah.
but I don't know about the calibration in terms of how much, I know what you're talking
Yeah,
about, the
yeah.
range part, but...
Because I remember one of the things that we use
Yeah.
with a cool spectrophotometer, we got the small range because the thing that we're measuring was very, very light.
That's for accuracy, but those we do in our, high-tech systems,
Right,
we
right.
get to like 0.1
Yeah, right.
NTU accuracy we
right,
need, but in
right.
this one, the variation or the error in this one is more than that. I mean, so maybe a 1 NTU error is not a big deal in this.
Yeah,
this
right,
unit,
right.
because of
In
just
their,
like
in
this.
their case, I don't think it matters.
It matters that
much,
much, yeah. So that's why, because when I was doing the calibration, I was looking for that for setting the range,
Yeah.
but it's for
But
that
this
range.
was to verify that
Where is it?
100 is one about 100.
Yeah, so that's what they're trying to verify, that for calibration, they want to make sure that, okay, what you're testing out is 100. It shows out here, to the accuracy and the specifications. Sensor range is about 0 to 400 NTUs. Accuracy is from 0 to 20 NTUs, it has an accuracy of 0.2, okay, plus minus. And from 20 to 100, it has 0.5. Beyond 100 NTUs, it becomes plus minus 1. That's what I was saying. So that's why 101.1 is within the range.
Just to give them a little bit background on the technology here, the spectrophotometer, we worked with an Apple IIe, and we did it for several science projects, and then, but you would get that measurement, which would be like a turbidity measurement. And then, so sometimes we needed to calibrate the range. We can use food coloring and stuff like that, but you set your low end and your high end, and then you would divide it into the units, right? So the normal, then the finer units you can get. But it's amazing because you can crank out numbers. We did bacteria studies on this for turbidity because you don't want to grow the bacteria. But you can see the more turbid it is, the more bacteria grow. So we were able to crank out numbers for any kind of bacterial study without having to fool around and mess up with any kind of growing of bacteria.
Okay.
Yeah, nice science projects, go for it.
I know, right?
Oh, nice.
This is where the you know the fun part comes, where visually if you show your students, okay, you can tell, but it's like, you know, close. So it's like this one is the golf course one, so you can tell the difference on the two. And now that's why the turbidity meter is going to give you like the exact range on how
That's why I said,
well
if
we
you did a
did.
sticky device, you can show them, man, how can you quantify something like that, right?
Yeah, that's
Now
right.
you can quantify the
The
thing.
water is not clear.
I know.
Our hypothesis is it's not clear.
Okay. So starting with the golf course.
Golf course.
Because sticky was used
You have to
for
fill up the whole
years and
container,
years
yeah.
in the
Yes,
sticky disc.
to the brim, like, to the
Yeah.
neck of the ball.
Because I usually use this, funny.
Even still in the course you took on turbidity.
What's that?
I don't think he knows.
No, I need to be
Water, you know, from the
like,
river.
Who's going down there?
It's all
Kids.
boxed in and then
You like test the water
making
over
us do
there.
some stuff, but I
So when
have
you're
no idea
running
what I'm
through
doing.
it, you know what you're
Because he's
running
just a
through.
professor and just tells us. I
And
didn't,
then
if I
there's
knew about
testing
that, I would
difference
have taken
between
that
running
PE
water
class.
versus still water.
Oh yeah, you could do that.
Look at that.
This is for the golf course. So or like what, 23.6.
So the lower it is, what does it mean? Like
Yeah.
the
How much
There,
water?
yeah.
How
How
much
much is it?
suspended particles are there in the water? The turbidity is like how milky or
Yeah,
like, you know.
cloudy.
So the higher
higher
number
the
is-
more
Yeah.
cloudy it is.
So pretty much you are now, this is gonna measure the performance of your sediment filter, which is
Okay.
supposed to take care of the suspended solids or sediments or rust or anything. So that's why the water is coming out cleaner than it went in. And that's what you're measuring now. Because there's an acceptable range. I do not have that on me. I can send you those numbers of what the Thai military considers as an acceptable range for all these parameters. That the turbidity has to be less than this, that the ammonia, pH, nitrate values have to be less than that for us to be sure that we can drink this water. And the E. coli has to be 0, the coliform has to be this level. So all those are called our baselines, that okay, we have to meet those standards to make sure that our system passes the 14 parameters that the Thai military set for us, so that it is considered potable water.
So what you have there is the golf course water?
Yes.
Okay, now
Okay.
do you have the other one?
Yes, I'm gonna do that afterwards.
Okay.
The carbon filter doesn't filter that much sediment. You have to have a separate sediment. If
Yes.
It doesn't do sediment.
No,
Okay.
carbon is mostly for taste and odor.
Oh, okay.
Yeah. Okay, let's do the filtered water now.
Yes.
Because that's
Said
what I
earlier.
And then
have.
distilled water.
We have a carbon filter on the
Yeah.
turtle tank.
You
Oh,
put some
okay.
distilled water in one of them?
Yeah.
Yeah, okay, good. I wanna see how good the filtration system is. See, look, you want variables and cranking out different numbers. I was thinking about how we can get these different numbers going. We can do work on filters, like, what if you use a filter 50 times? You know, the filtration, you know. At what point do you have to change the filter, you know, like you're saying, right?
Yeah.
Like you said, it's hard to say because it depends on the sampling you use.
Right,
Yeah.
right.
But I guess they can try to figure that out themselves.
Yeah.
Clean.
Oh.
Oh!
Which one was that?
Wow.
The distilled.
The filtered
Oh,
water.
Filtered water from
Oh,
this.
filtered.
Yeah.
Oh.
Wow.
The one I took from this bowl.
Nice.
So that's a green line creating. So that's a difference. You can show 22 to 0.
Yeah.
Nice.
I don't think distilled is gonna do any better than that. So there you go. That's the performance of the system itself. So you clearly see it's 0 NTUs.
Yeah.
Well, see, you can drink it.
Oh,
well,
that's
it's a
very cool.
Sorry, sorry, my
No, I
bad.
gotta see the
Yeah,
bacteria.
bacteria.
From that. No, that's what I say. If we cannot get that service, then I think what the way we prove it to the kids is show that they already have done data testing on the, on the machine
The
itself,
UV,
and we can just show them that that's what happened. So trust us, it's good. Because
Well, if you don't hear, drink it and see what happens.
Okay, so yeah, as good salesmen, we stand behind our product too.
We're gonna drink that water.
Two for me.
All right, next. Next is phosphate, ammonia,
That's the ones we have trouble with, phosphate and more.
nitrates. So
Nitrates, which are really.
this we need a colorimeter for this particular testing to be done. Disconnect this.
pH was the acidity and the, oh yeah, that's it,
Yeah.
that's it, that's it, that's it.
So you want it to be 7.
Yeah.
What was I saying? Okay, this is how.
so which ones you wanna take home today? You might as well take home today, then I don't have to deliver.
No, that's fine, it's
We
like
can-
I live
we
close
can-
to you, I can pick it up either way, so, doesn't matter. Cause I'm not the
you
science
don't-
person, so I'm,
No, but you don't fool around with the iPad, right?
oh yeah, yeah, I
But you
mean,
both don't have the iPod.
no.
No.
We
We
don't have
Yeah.
iPods to give out, right? All the iPods are gone.
I mean, whatever you can give, then if I can pre-set up everything.
Yeah.
Oh, no, I cannot pre-set up everything, but I mean, we can still
You-
practice with it.
With the iPad.
Yeah.
Because it's the same.
Yeah.
We
I'm
don't
sorry,
have
I need
any
that
more,
for the
because he's gonna get the
No.
one.
These regions that you have to add, and only then you can, from the color of the water is what you're trying to test.
So this is still colorimetric to
Yeah, this is a colorimeter now.
Oh.
That's what I'm using. So
Oh.
water quality colorimeter.
That's phosphate and nitrates are like that.
Yeah,
Oh.
we're gonna do the regions first, and then we're gonna test it using a
Oh,
colorimeter.
so in that sense, it's very similar to the Lamont kits, because the Lamont kits you're doing, and you're just comparing the
Yeah.
color
Yeah.
with the color chart.
Hey, Sean.
So now we're gonna crank out a
Do you have
number.
a spare battery?
Okay, so let's
Battery
again test.
for that?
Yeah.
No, it has to be the.
Golf course water?
Yeah.
You wanna do that?
Yeah.
Okay.
So actually, you guys are what, engineers?
Who?
These guys. Oh, these guys.
Engineering students.
He's an engineer.
Okay.
He has an
Okay.
engineering degree. Sean and Paul are
Computer science.
computer science.
Oh, okay.
They are programmers.
Yeah.
I'm
Wow.
just curious, cause, okay.
But, they're techie, so, things like the Fab Lab and stuff
Yeah.
like that, anything that has to do with equipment, they pick up pretty fast. I only prepare food. So today, you're welcome to go and have lunch. Let's go out, Maroon Market Break.
Okay.
Gotta keep it simple for them.
Nitrate. So again, I'm reading this from the thing. If you want information on why all these things are getting added and what is going on in terms of the chemical reactions and how we're trying to extract the nitrate sample, then you can read on the Pasco sensor thing. So first step it says is fill the reaction tubes. That is like this one, 15 ml of the sample you want to test. And then these are these zinc foil packs that they have given. So he's saying that pour one of these into your sample.
I don't have to explain what all that stuff is to the kids, huh? Just tell them just pour it in.
Yeah, and this is it, I know with your kids, you just gotta make simple steps.
And with a
You want it,
picture.
you're gonna need to read the instructions.
Yeah.
So I'm gonna have to have.
And that in
Kids
itself
are all
is
about
a
the
lesson.
YouTube now, yeah, so.
Yeah, now they have their phones of their
Step by
3G or their 4G and they're
teachers
just,
too.
Yeah.
you ask them a question and, oh, here it is.
So, that's it.
Yep, so-
You look at the schools that have
Everything
been
video, put it
successful.
on.
Like, Jared's,
interest.
Jeffrey Lim, he does a lot of stuff like that.
There's only
He
2 minutes
has
you're
a
gonna show
special
them.
Some kids actually,
breaks.
they'll
He'll be
find their
very
own things on
helpful. You
YouTube
get
and they'll come back
somebody
knowing
who
stuff.
break down every lesson.
Yeah.
They have some
AJ
of
gets really into.
Yeah, I don't have
They have
that.
some of
I
my
know,
stuff
that's
on
why
I do
YouTube.
videos myself that actually listen to us when we're on the video, but they won't listen to us in person.
Sometimes I want to do it, sometimes I'll like record one period where I'm talking, then the
Yeah.
next period just play it and then just go around and
But that
clap
would
it.
get their
I mean,
attention.
how
Yeah, 'cause it's a screen.
You have
Because
to
it's-
like that working with you, right?
I should do that with my
Makes
kids.
life easier, less stressful, man.
I mean, as
Try that,
it
that's
is, you have so
Or like
much
when
to
you're
do.
gonna be absent for a
But
day.
what a
just,
thing
Yeah.
effort that is, just, I'm so impressed with
Yeah,
that,
because
that special ed teacher that works with Jeff.
Yeah.
So,
And you only have to work one
I'm just trying
period.
to figure out.
That's right. And they can even like pace themselves so they can like have an iPad, so
Uh,
there was a pause, yeah.
So I'm try to come down now. We're
If we ever get a
working
big-
with it because
big grant,
every
a
school
big
is
field
different,
thing
every
going
bunch
on.
of teachers are
Need
different.
bigger
And
LCD
I
screens.
set up my whole system.
No, they
with
did.
Social
Social studies just got the
Social
new
studies
ones
got the big
in.
one.
But I know what you
Kara got
mean.
one, right?
It's
So
deep.
these
50
people, like, they
I
have
don't know.
a great.
Almost
Ours is
50.
40,
40,
40
math
something.
and science working together. So whatever they do, they know, this
And then-
meeting is important because now the math teachers know this side and the science teachers know that.
I know that
So
Peter's
people-
gonna move back to the
2
classroom.
minutes
Oh,
you need
is
to
he?
like shake the sample.
He found out the way you
Yeah.
found
That's what
out.
I'm waiting for.
Right,
He,
even
They
he looked at the
did
line like, oh.
They have to
Oh, they didn't switch
count
it
how
back?
many
That's not
minutes,
possible.
yeah.
Oh, I'm not sure.
Study skills.
I don't think he wants to. I think he likes it,
He's gonna teach study
Because now
skills.
Jennifer's leaving so that he can
Yeah.
move into the 6th grade science line.
but he doesn't want to do all. He want because right now
Likes-
the one he's slotted for is 1 science and 4
Studies.
Team
team.
biz, yeah, I don't know why he
Oh,
would
team
have done team
biz.
biz.
Team
Yeah,
biz is-
all on the computer. You just
But that's,
keep kids on.
I don't see why. I think Peter, I'll take that. Like,
I know, I'll take that one.
It's just gonna go team
Team
biz.
biz is just to make life easy for the teacher, but, you know, I just don't think how much they're really learning in terms of skills.
yeah, skills, right?
And
They may learn how to
it's good
read and they are
independent.
thinking.
Yeah.
It's a good
right?
lesson for
Yeah.
independence.
Then they have this
Right.
acidifier solution, and this is a different sample cup. So you have to add 10 drops of this into the sample cup.
Oh gosh.
So this one you have to
I
shake
can
for
see
60
the
seconds.
kids like miscounting.
So oops.
Yeah, I know.
The stream of it, yeah, coming out.
Okay, now you're going to transfer the contents of this one without transferring, the solid zinc particles on the bottom. You're going to leave this in this container, so just spike transfer.
Okay.
So try to avoid the
So the zinc stays.
zinc stays in the
If we
original
were
cup.
to put a mesh above it for the kids, would that affect the
I don't
the
think it is.
chemical,
Yeah.
whatever?
But if you go slowly, I don't think the zinc is going to transfer. See, I mean,
I'm just
very-
trying to foresee all our kids.
Yeah, don't pay
Hey,
attention.
Stays behind.
stays behind very easily.
Okay, okay.
I mean, if you're not doing that,
Yeah.
it will stay behind.
Okay.
I mean, very easily.
Just gotta be. real
Okay,
cautious.
so that's your sample.
Is this a-
Okay, and then they have these vials. Okay. These ones. Now, this tip has to be broken inside the thing. Okay, you just press against the side and it's going to break the tip. So watch. And then it absorbs the sample. Okay. It was a reagent, this much reagent in it, and then when I broke the tip, it absorbed the sample from the cup. Now you just like rotated the air bubble from one side to side so that the sample is
So
mixed
we don't want the
properly.
kids to do that, right? We gotta do that then.
I think you should.
Yeah, you should do it.
Breaking these
I want
vials.
to say, oh.
That's why, but I can even see another in intermediate step. You can let the kids do the Lamont test taps, with
Right,
those
right.
Yeah.
taps that they drop. And then colorimetric way and getting this very crude, inaccurate device.
Oh,
And
10
then you
minutes.
bring your sample up and if that's like a sample,
I don't have to shake it, I have to put it down now. So then once this is done, it's gonna go into the colorimeter
Colorimeter.
and then we check the values.
Again.
Good.
Okay, that's your first sample. Similar concept is followed in the
Yeah.
phosphate and ammonia, so we don't have to go through all of them. They pretty much just want to demonstrate.
So, that airlink thing or whatever, it's all set, once you put this one in for,
For the
what is this phosphate that you're doing?
this
Nitrate,
one is
nitrate.
nitrate.
Nitrate, okay, for the nitrate one now,
We have to recalibrate.
it's already calibrated.
it's already
calibrated.
For nitrate,
Nice.
so all you have to
It's-
do is to put that in and get a reading.
Yes,
So-
but select the right measurement.
Okay.
That you're in nitrate. So on
Now-
the drop-down list, you got to select the measurement and that nitrate.
What fits into that little cavity there, only this?
This whole thing goes in and then
Yeah.
you close the.
I was wondering if there's another thing that you could put in.
Another thing.
Like a test
You know,
or
like-
something.
Yeah. In other words, what I'm thinking about, if you don't want to eliminate all that chemical thing, the easier one is the Lamont one, because you just
And
drop
then
a
transfer
tablet.
the liquid into another container.
Right, and then put it in there. Instead of that device
The
there.
trick is finding a container that fits then.
Yeah. Well, we had, this,
Oh,
they
really?
made this
Do you
little
have
test,
test
because when I
tubes
did
for
that,
Lori?
So
the
this picture is
spectrophotometer at school.
They're a
they
little
have a
wider
2E.
diameter though.
Oh.
That's
Amazing.
why I asked her, can you give me
But it has
like
to be
what?
glass.
I'm not a
yeah,
supply
because
store.
plastic won't work.
I know, she just
So-
got
It
in
has to be
like
glass.
Yeah,
10,000
glass.
plus.
Right.
Yeah.
Oh no,
It's
hers is
plastic.
plastic.
Once I
Yeah.
connect to
Yeah.
the.
I have
colorimeter,
glass.
Yeah.
On the units it shows sulfate,
There you go.
phosphate.
Guess we could try.
So nitrate is what you gotta select.
Oh.
L or the H?
Oh, I didn't notice that. Yeah, the low and the high values. That's a good question. Okay. If the readings are above 1 milligrams per liter, then use the nitrate high reading. If the readings are below 1 milligrams per liter, then use the nitrate low reading.
Okay.
So then we can only judge once we get the readings.
Oh,
Okay.
Again, the menu shows nitrate, sulfate, phosphate, so you can select which
But
one.
since you're gonna do it, it doesn't matter, you might go, as well get the kid and run it through. Because that's, you're not gonna let the kids do this. Right?
Well, I'm trying to figure out because if I'm gonna do breakout sessions with each kid doing a different experiment.
No, but then do the Lamont, right?
Right, so for,
Yeah.
oh, okay.
I
So
don't
I
think
just
the
run,
Lamont, the kids
so
can
all
do
the
it,
kids
and
do
then you
Lamont.
just pull
Yeah,
it
okay,
together,
then
I do all
and they
the-
can compare the
Yeah,
results against
so once they
ours.
get the Lamont data, then on another day, you will do it as a demo
Yeah.
using.
Yeah.
Oh, probably
the
get this one
Pasco.
now.
Okay, I see what you're saying.
Yeah, so you need to kind of practice the thing, and if you run into difficulty, then there is that tutorial.
After the new one.
But then, you know, they're also available for answering your questions too. So you're gonna take home the ones that you want that matches with the readings that you're getting from the Lamont. And then you folks just would take, you have your vernier, I have it in my.
Okay, I'll take it back.
But then, you know, you may want to do now the Pasco stuff.
Yeah, it seems easier than, I don't know how to use those probe thingies, that's why, I think
The
only
vernier.
Ray,
Yeah,
yeah.
this one, this is actually
This one
easier.
seems easier that we can do it.
This
and
is
just
quite
important.
get somebody
Okay.
else to
Yeah,
do it.
Because,
just wait iPad if you don't want that.
So how long did we have to leave that out for?
10 minutes. It
Data
says on this
logger.
sheet. so
Data
you-
logger.
It says
Vernier,
it
I
on
think.
that.
Okay, it's on the instruction.
It's on this
I
one.
don't
Alright.
know, like you can do that first, and then while you wait.
This one,
Mhm.
yeah, 'cause
Yeah, that
It's
seems
high.
like the only part.
So you folks have 2 6th grade teams.
2 7th grade, no, wait, three 7th grade teams and 3 8th grade teams.
Oh.
So,
Point
2 of the
02.
teams have more of the advanced kids, and I'm the team
Milligrams per
with
liter.
Well, that's pretty
And
good,
that
I
is
think
what?
you want
whatever they
0.
got.
Oh,
All
yeah.
the
As
And
opposed
that's
to
for,
0.
that's from
It's a
the,
list.
See,
I don't have the
this
standards, but it's
is
fine.
powerful.
It's
When
within
they
the
do
range
this,
of.
they're
I've
So
heard
this is
of
a-
the nitrogen,
it came out of
I
this
think
one,
too much
the
nitrogen
unit.
in
No, this one
water
actually came,
kills
it's
it.
directly golf course
Oh,
water.
okay.
We didn't.
That.
Ray
direct
and
to that.
Mia is on one team, and Curtis and Jill is on another
Yeah,
team.
right, like
So
too
when
much
they do
nitrogen
this,
in the
and now you
water
have
causes
two
fish to
teams
die or
now
something
involved.
yeah,
like that,
I
yeah.
think, yeah.
Yeah.
You know, when they go on a field trip, they don't take all like
What helps
300,
with
you
plastic?
know.
Oh, wait,
But I'm not sure what that level
People
is.
can only take 100, that's all they can.
So how do you guys
So
figure out who
basically,
who's?
Activities.
Yeah,
We do activities and behavior.
free activities, and then, yeah.
behavior.
We filter them.